Walk on to any major construction site before the turn of the millennium, and you'd find a forest of wooden stakes planted in the dirt. For decades, these simple pieces of pine were the primary interface dictating exactly how heavy machinery would shape the physical earth. To an experienced equipment operator, the markings written in Lumbercran told a complete story. A sequence like SSC 3.0, 4-to-1 slope, was a direct command. It told the driver this was a slope stake, instructing them to cut 3 feet of dirt and to find the exact angle of the embankment they needed to carve. But calculating and placing those commands in the 1950s was exhausting manual work. Survey crews relied on physical tools like these heavy, sliding wooden Philadelphia rods to measure elevations, doing tedious subtraction by hand in field books to figure out every single coordinate. This analog process was slow, but it required the crew to physically verify the ground against the paper plans at every single step. Under the original liability structure of post-war construction, the project owners or their engineers provided that survey layout. The people who designed the project were the ones physically walking the ground. This setup allowed for something known as the quiet work. Because paper designs rarely match real-world topography perfectly, these on-site survey chiefs used their authority to smooth out transitions and adjust curves by eye, fixing minor design flaws before a bulldozer ever arrived. Then the legal landscape shifted. Faced with rising lawsuits and expensive delay claims in the 1980s, project owners decided to push all layout responsibility entirely onto the general contractors. This created a massive bottleneck. Contractors had no legal authority to adjust designs in the field. If a surveyor spotted a flaw, work ground to a halt. They had to submit formal requests for information, waiting weeks for off-site designers to approve a fix. To survive this hostile new legal environment without going bankrupt from delays, contractors had to drastically accelerate the pace of their layout work. The initial response in the 1970s brought the first wave of electronics to the job site. Early electronic distance measurement units introduced red LED displays, though they required surveyors to haul around heavy 12-volt lead-acid battery packs clipped to their belts. But the massive leap forward arrived in the 1990s with the integrated electronic total station. These machines took the fragile precision ground glass scales of older optics and consolidated them into weatherproof housings featuring multi-line digital screens. The total station replaced manual arithmetic, saving hours of field calculation that previously dominated the surveyor's day. Instead of writing coordinates in a book, crews could now upload digital CAD files directly from a computer into the instrument's internal data logger. Add in motorized tracking heads that followed active 360-degree prisms, and a single operator could suddenly lay out points at blistering speed. The hardware would physically whip around, achieving an instant lock on the target as the surveyor walked the site. Despite the speed of the new digital workflow, contractors continued to plant physical wooden stakes in the dirt. Technology solved the speed crisis, but those pieces of wood remained a vital visual safety net, keeping human intuition firmly in the feedback loop. Fast forward to a modern construction site in the 2020s, and traditional survey stakes have largely gone extinct. Instead of plotting individual coordinates, crews now use drone LiDAR mapping to instantly capture millions of 3D surface points across the entire project. And the heavy machinery itself has become the surveyor. Through 3D machine control, bulldozers and excavators are guided entirely by satellites and onboard digital models. As the operator drives, the onboard computer reads the 3D model and automatically adjusts the hydraulics. The blade moves itself up and down to cut the exact design elevation without any manual intervention. The physical earth is no longer shaped by human notes written on pine. It is carved directly by unblinking, perfectly obedient algorithms. But removing that human buffer has created a dangerous new trap. When an automated grading error occurs, the chain of blame is fractured. Is it the equipment operator, the software provider, or the engineer who built the file? An invisible vertical error buried deep in a 3D model goes unquestioned by the automated machine. And without the physical visual aid of slope stakes dotting the grading limits, supervisors can no longer look across a field to see if a cut looks right. They have to rely entirely on expensive GPS screens, checking a digital map instead of trusting their own eyes. When a coordinate is wrong, the machines carve that error across acres of land with perfect precision, day after day. Automation has given us incredible speed and accuracy. But as we build the future of construction, we have to look beyond launching better satellites and figure out how to build human intuition back into the loop.